The broadcast is now starting. All attendees are in listen-only.
Hello and welcome to today's webinar, sponsored by Astrix Technology Group, entitled Master Data Design Considerations. Go next slide, please. Before we get into today's session and the materials, I want to first take a moment and introduce Astrix Technology Group to you. If you're not familiar with us as a company, we are an informatics professional services and staffing firm dedicated to serving the scientific community. The company was established in 1995 and is privately held. It originated in the IT division of a company called APBI, which was a $3 million life science research organization. Today, we operate from 7 offices in the United States and Costa Rica, with headquarters in beautiful Red Bank, New Jersey. Who we help is target customers in the Fortune 1000 life science enterprise, chemical, CPG, government, and research institutions, typically with large and fast-growing IT and outsourced and compliance needs. Our mission is, and always has been, to deliver scalable, sustainable solutions for the scientific community. Next slide, please. Now, the group you're speaking with today within Astrix is our professional services group. And our professional services group is built to deliver end-to-end services which span the complete life cycle of your scientific data systems. This includes everything from helping companies with business process analysis, trying to understand what technology they need to match up to the different business objectives. And then we enterprise architect that solution, which is basically helping to design a solution or series of solutions that are interconnected. From there, we will help with laboratory technology selection to make sure we're picking the right technologies to put into place. And then, of course, the development and implementation of those technologies. Finally, we engage in more compliance-related activities like computer systems validation. And then there are additional services on the back end, such as 360-degree laboratory services, which we can help manage and maintain your laboratory software. And then there's also the ability for us to staff the right technical and scientific professionals in your organization to manage and run your systems. At the end of the day, we help with evaluation, implementation, and management of systems to enhance the collection and processing of scientific data. This is what we do, and this is what we specialize in. Next slide, please. So it's my pleasure to introduce our speakers for today. We have Ed Peliquin and Bill Halliday. Ed has 14 years of experience implementing labware solutions in the global life science, contract lab, and manufacturing industries. He has extensive track record of driving success and delivering value to client projects. Bill brings 10 years of experience implementing labware solutions in the global life science and contract research organizations. So I'm going to go ahead and turn it over to you, Ed, and I'll let you kind of work your way through the rest of the presentation.
All right, thanks, Kevin. Actually, today we're going to have Bill start out. So Bill, just let me know when you need me to do the slides.
Sounds good. Go ahead and next slide, please. So the first thing that we're going to start with a brief introduction as to what master data is and why it's important. A LIMS implementation usually requires a incredibly large investment of time, money, and resources. A LIMS implementation will typically cost hundreds of thousands or millions of dollars and requires hundreds of person days to accomplish. And one of the most important facets of any LIMS implementation or migration is the design and configuration of master data. Very often, what companies do is they will focus on testing and configuration and leave master data until the end. It can very often become a project blocker or at a minimum a critical path. Then it gets done quickly and with sometimes not the appropriate resources, as well as designs which haven't been thought all the way through. And master data design configuration is typically a much bigger job than we think it is when we're going into the design or development phase of a project. Next slide, please. So just a couple of definitions. As we go through this this presentation, we're going to be focusing on how to make sure that our master data is both maintainable and scalable given the design. And I like these two definitions. The definition of maintainability, the ease with which a software system or component can be modified to correct faults, improve performance or other attributes, or adapt to a changed environment. And then for scalability, we're really talking about the capability of a system, network, or process to handle a growing amount of work, or its potential to be enlarged to accommodate that growth. Next slide, please. So just a quick audience poll.
Yeah.
What is your role relative to Labware?
So I'll go ahead and launch this actually. So this is an interactive poll. So we'll go ahead and select this, and we'll go ahead and launch this poll. Everybody should see it up on their screen right now. We'd appreciate it if you could take a moment and answer that to the best of your ability. And then we'll share the responses with you as they come in. So usually what I like to do is leave the poll up for I'd say about 60 seconds. I think that generally gives everybody an opportunity to answer. I just want to make sure everybody is aware that your answers are anonymous. You know, there's no tying this to your record. So you can feel confident that these answers are not going to be shared when we display the results. We'll get about 15 more seconds here. Okay. All right, we're going to go ahead and close that out. And we will share that information with you. So this is what is your role relative to the Labware. So we have the highest was other, and then we have tied up at 18% was LIMS administrator and developer and technical support, followed closely by business owner, and then finally the lab manager and analyst. So thank you for participating in that. We appreciate it, and we'll go ahead and go back into the presentation mode.
Thanks, Kevin. And so we'll be moving on to a brief overview of master data. And to note here from the diagram is essentially that master data really is at the core of any LIMS system. There are generally two kinds of data in a LIMS system. You have dynamic data, which is going to be things like samples, tests, results, batch and lot records, that sort of thing. Dynamic data consists of data that it's created repeatedly. So very often in a system such as Labware, you'd have something like a sample template that defines what attributes get captured when a sample is logged. Static data defines the structure of the system, and it's commonly referred to as master data. And before the system is able to generate dynamic data, the static data has to be configured. Master data consists of the data used to generate samples, tests, results, and other dynamic objects. An example would be, as I said, a sample template, which determines what data needs to be captured when a sample is logged, such as product, sample type, location, or temperature. Next slide, please. So master data has critical impacts over the life cycle of a LIMS, and a failure to pay the appropriate amount of attention during the design phase of master data can lead to some pretty serious issues. Some things like you know, a lot of difficulty in adding or maintaining data as the system matures and grows, decreased efficiency and reliability. Future enhancements sometimes can be resource intensive depending on certain design decisions, as well as more challenging management for large volumes rather of data, decreased user acceptance, and of course the most important thing, decreased return on the hundreds of thousands or millions of dollars that have been invested in the LIMS. Next slide, please. So the first part of a master data plan is a formal document which is going to identify some of the following pieces of information. So the first thing would be a list of all of the master data that needs to be put into a system, things like instruments, analyses, products, any units or particular user roles, workflows, that sort of thing. The schedule for when specific tasks need to be accomplished, as well as by whom. And I would just like to mention that it can often be beneficial to have someone who is designated as the master data lead and who is really tasked with driving master data to completion, as well as being involved in design, sort of all of those pieces. A schedule for, I already said the schedule. The places where the master data is created, and this could be external systems which can be integrated. So an example of that might be an instrument, a system that keeps track of instrument calibration information and asset information. You could have that integrated with the LIMS so that when calibration or maintenance information changes on the instruments, it can automatically update the LIMS. The master data plan should also include people who will be doing the work of entering and testing the data. And it's also important to note that these people should have appropriate training for the job. And frankly, the more technically minded they are, the better that seems to work out. The plan should also include how data is transferred into the system, a rationale for why certain design decisions were made, things like naming conventions, custom functionality, and another one that I'd like to mention as well as reserved words. So sort of part of the naming convention would be to document any reserved words that that the LIMS won't allow you to use inside of names. So it could be like, you can't call a sample sample, you know, as an example. So all of this sort of stuff should be documented in the master data plan. Next slide, please, Ed. So Labware is a generic flexible system. It's designed to work across multiple industries, and sometimes the terminology doesn't match well with the business term. And so an example of that could be in Labware. There's this notion of something called an analysis, where many people in a laboratory would refer to that as an assay, as an example. And so if these things are renamed, which can be done in almost every LIMS system, it should be documented as well. For example, if you're going to change something like item code to be part number instead. And then where data is duplicated across systems, such as the instrument calibration information, it's important to know which system is the source of truth and why is that system the source of truth. So for example, if you have your instrument calibration system disagrees on a particular calibration date on a specific instrument, you know, you have to know which one actually will take precedence in the event that there's some kind of mismatch between the two systems. Next slide, please. And so the next thing that we're going to be talking about is master data design, but before that, there is another audience poll, so I'll turn it over to Kevin.
Thank you very much. Yeah, we're going to go ahead and get that launched here for you in just a sec. All right, so you should be seeing on a screen, which of the following issues have you experienced with your system? Difficulty adding or modifying master data, defects that are hard to identify and correct, increased resource requirements or future enhancements, difficulty supporting additional locations, and difficulty supporting more dynamic data, such as samples and tests. So we'll leave that up for a moment here. Give everybody a chance to think about their answer. Appreciate everybody's participation. Again, your participation is completely anonymous. And we'll give it about 15 more seconds. I'm going to go ahead and wrap it up. So I want to thank everybody for participating in that. We'll close it out and we'll share those results with everybody. So coming in at the lead was increased resource requirements for future enhancements at 33%. And right behind that was difficulty supporting more dynamic data. Tied up was difficulty adding and modifying master data and defects that are hard to identify and correct. And nobody had selected difficulty supporting additional locations. So again, I want to thank everybody for participating in that. And we will go ahead and pass it back to our presenter.
Thanks, Kevin. So some design considerations as it relates to master data. One of the most important aspects is obviously understanding what data needs to go into the system. Very often this requires scheduling an assessment of the data to determine what needs to be classified as master data and the master data entities in the LIMS being implemented so that you can know which ones you're going to use and how. The assessment can be used as an opportunity for you to do some house cleaning on your data. So you might decide not to add master data for any test that's older than 5 years, say if you were migrating from a legacy system. Next slide, please. So one of the things that we mentioned a little bit earlier was naming conventions, and to go a little bit more in depth into that, where possible, it's usually a good idea to keep things like analysis naming conventions generic rather than specific, and then to use product specifications and variations to drive behavior. So, for example, a product specification can determine the reported name to specify and the actual name of the analysis. It can also set the variation, replicate counts, whether the component is required, reportable, etc. So this is a way to sort of make the design a little bit more modular so that it's more flexible in a wider variety of circumstances. And every LIMS system, as I mentioned before, does use reserved words that can't be used in naming, and it's important to document those along with any naming conventions that are used. So in general, a generic analysis will allow for easier long-term maintenance. It will reduce the overall amount of master data, but it can be a little bit more complex to design and implement. When you have specific analyses, the long-term maintenance is much more difficult. It usually leads to a larger volume of master data, but it can be simpler to implement. And this is why, we mentioned earlier that sometimes, you might, if you leave it until the end, and there's a huge amount of data, it might be more tempting to take the simpler path, even though it may not be best in the long term. Next slide, please. And then regarding summary analysis, so this really comes into play when we're dealing with interfaces. And one of the things that you can do is you can organize it into two analyses, one for the raw data that comes off of the instrument, and then another dependent summary analysis. So the summary would essentially be a child of the raw data analysis, and then you can add multiple test replicates and summarize them much more easily. So when it comes to summary analysis, it does require some additional master data, but it can allow multiple replicates to be summarized and isolated, and then you can also auto-authorize the raw data. When you're using a combined analysis, so this would be one big analysis with a number of components, the design can be a little bit simpler. But it makes replicates more difficult and messy, and it also makes it a little bit more difficult to auto-authorize. So those are some important things to keep in mind when using interfaces. Next slide, please. And then when it comes to object naming, very often what I've seen happen is that companies tend to want to recreate whatever structure existed in a legacy system in a case where systems are being migrated from an old system into a new LIMS. So changes to the old system would then could have second and third order effects on the LIMS. And because the underlying structure of a previous system can vary pretty widely, it usually doesn't make sense in the context of a LIMS to replicate the previous data. The downside to that is that it might require the business to change some terminology. However, what you gain is that changes in the external system will then not affect the LIMS going forward, and object names will make more sense in the context of the LIMS. Using the legacy object names, obviously the business doesn't have to change as much, but then any changes to that system will almost certainly have effects on the LIMS, and the object names may not make sense as much sense in the context of a LIMS. Next slide, please. And then regarding metadata, so metadata is really data about data, and the simplest way to think about that is, when you write a Word document, the company name and your name and some other data about that document automatically gets generated. And so that's an example of metadata. It's really data about data. So the idea here is not to tie metadata to a name or key field in the database. Very often it can be better to add a field instead. There are some scenarios where tying metadata to a key field may provide some value, but in general, it's something that we try to discourage. So when you have metadata not tied to a key, it's easier to deal with source of truth systems, but it can be more difficult to search for that data. When you do have metadata tied to a key, it can be easier to identify some objects, again, provided that the source system doesn't change, and the keys are usually indexed, making the search a bit easier. So it's a bit of a trade-off there. Next slide, please. And then reporting. Ultimately, in my view, reporting is probably the most important aspect of LIMS, and it can often be overlooked when you're generating or designing master data, what the actual reporting implications might be, but it can have a direct effect on the ease or difficulty in getting clear and concise data back out of the system for reporting purposes. And so I like to think that it really is best to begin with the end in mind. It's much easier to add a field to a table that you would commonly report on, such as sample test or result, than to have 6 or 7 or 8 joins in a query or report in order to get to the data you need. And one example that came up for me personally recently was, we have in our this project that I was working on, they had a whole lot of product specifications for various item codes, and the suppliers for those parts are actually on a child table of the item code. So ultimately, in order to get the supplier for that particular part, I had to make I think it was 5 joins in order to get to that table, and that's a instance where it might just be easier to add something to the report or even to the product spec that pulls in the supplier at the time that record is generated. And it can often be the case that a vendor or customer name, you might need a vendor or customer name on a final report. And that will require a number of joins, as I just said. So if you consider reporting when doing the master data design, it can make reports much easier to write and maintain. The necessary data will be at the object level, and because you're not having to ask so much of the database in terms of joins, the performance is generally a lot better. If we don't think about reporting in the design of master data, it will almost certainly increase the complexity. Related data will require a lot more work to get to, and more complex queries will then reduce performance. Next slide, please. And one of the other things that sometimes is overlooked is team structure. Master data, as I've said, is critically important to the overall success of any LIMS project. So having the correct team in place can be incredibly valuable. On larger implementations, it is recommended to designate a developer as the master data lead, and they should work directly with a counterpart on the business side. The master data lead is usually responsible for the data migration strategy and execution, and they would work with the business to develop a template that would allow the business to gather its data, as well as assist with extracting data from other systems if applicable. So sometimes it can be, if you have a developer involved in getting the data out of a source system, sometimes because they understand the data structure, especially of the LIMS, they would be able to structure that extract in such a way that it would facilitate bringing it into the LIMS a little bit easier. So the pros of having the correct team are going to be a smoother implementation process. Issues can be caught and addressed early. You'll often end up with a more elegant design, and the entire process will go more quickly and smoothly, leading to a better return on the investment. Not thinking about the team structure, a team of qualified, or rather, bringing in folks to help with the master data in this way can sometimes be costly. But if you don't do it, there's going to be a greater chance of errors and unforeseen issues and a greater cost of ownership over the life of the system. Next slide, please. And now it's time for our case study. And so I will turn it over to Ed.
Yep, thanks, Bill. So what I'd like to do now is talk about a specific implementation of labware. So, up to this point, we've talked about, many design considerations for master data. What can go wrong if you don't consider it or spend enough time thinking about it. But I thought it would be very useful for you to see a concrete example of how we've, taken a look at a company's master data and help them architect a design and labware such that it really improves their quality of life when using the system, and being able to meet all the different requirements that they had with the limbs, so that the design can handle those those different use cases. So with that being said, so today I would like to talk about Global Labs, Global Laboratory Services. So they're a leading analytical laboratory in the tobacco industry. They're ISO accredited, and they're a contract lab, and they specialize in testing tobacco products. So that's hemp and e-liquids and all sorts of things like that. They're currently using Labware 6, but they were having some issues with it and decided that they wanted to move to Labware 7. So as many of you are probably aware, Labware is a fantastic system. It's extremely flexible. And when we're talking about master data design specifically, that flexibility can get you into trouble. All right. You can do things in Labware like many other LIMS systems. You can do it a dozen different ways. But getting it done the right way is, easier said than done. Okay. Labware was originally designed as a LIMS system, but primarily focused on manufacturing, like manufacturing of pharmaceuticals or just manufacturing in general. Their table structure is set up that way with products and sampling points specifically where you took the samples from. So sometimes changing terminology in the system can help make sense of that hierarchy, and that's one of the things we've done for Global Labs. So the reason why Global Labs reached out to us specifically because, like I said, they were using Labware 6, but they were having some challenges. And as the system was maturing, those challenges, those problems were sort of getting worse. So some of them, as I've listed here, they had a lot of difficulty maintaining the master data. So as a contract lab, they do testing for customers. So customers contract them to do the testing. And what comes with that inevitably is customers will want things reported a certain way. They'll want things, they want different, limits applied, or, there's various things that the customer could ask for. And since they're a contract lab, they're sort of wanting to, meet the customer's needs. So also with their system, much of, and like Bill said, reporting is a huge part of it. So for them, when they're reporting out the final results, their C of A's, they're sending these to the clients, the reporting was becoming very complicated because their master data design or their current design didn't help, facilitate all the things they needed to do for the customers in the report. So a lot of that customization ended up being implemented directly in the reports, which, as you can imagine, over time gets almost unmanageable. No instruments were currently integrated with the LIMS and their current workflows. And when I say workflows, I mean like their sample lifecycle, everything, like logging in samples, entering results, creating new what they call testing packages, which is a package of tests that they would sell to a customer as a unit. They had a lot of inefficiencies and just, they had some clunkiness there. So that's where we came in, and we spent a lot of time with them going over the current pain points and trying to come up with a new a new design, basically start fresh in Labware 7. So luckily for us, Karen is actually on the phone with us today. So I'm very happy that she's here, and I just want to ask Karen if, in her own words, maybe she can describe some of the challenges they were having, and what she felt would be the most important stuff that we focused on. So I'm going to go ahead and she's unmuted already.
Okay.
So Karen, you are unmuted.
Yes, I'm here. I'm seeing all this information on these slides between you and Bill, and it's amazing. You touch on everything that is true in our world. It has been a pleasure to be able to redesign version 7. I was terrified to try to just replicate version 6 in that new system, and it's been actually delightful to develop that master data in such a way that we eliminated so many redundancies in our system, so many areas that have been plaguing our reports, and just making things so much more complicated than they needed to be. So our version 6 had been through several admins, and people contributed different things to it, but the pieces weren't all together very secure. So version 7 eliminates all of those issues and a lot more. Our reporting, like you talk about with the joins, the table joins and everything, the gymnastics going through our reports can take up to 2-3 minutes to open up. So
Right.
I see the new structure that we've built in our system. If you want to go through more detail on that, those reports should open in seconds. We're streamlining the data. It's going to be clean, crisp, and I'm looking forward to rolling it out in the very near future.
Yep. Thanks a lot, Karen. I think it's always important to hear directly from a customer. Like, I don't want to misrepresent your concerns, but I want to make sure you get the opportunity to say, what the challenges are. So now what we're going to do is we are going to talk about the specific design that we put in place. But I think what's important before we get into the specifics of the new design, I want to talk about what they had going on in version 6. Now, for confidentiality reasons, what I've done here is I've sort of mocked up their version 6 master data design here, but just using some generic customers, just so that we don't have anything confidential on the screen. So in version 6, being a contract lab, they would put together what they called testing packages. And the way that they would do this is they would use Labware's test lists. So if you're not familiar with a test list, basically it's like a lightweight product spec definition without the product, essentially. So you can list out, and you can see on my screen here, you can have any number of analysis defined in here, and the components as well. You can change the reported names, their rounding rules, their limits. Everything you can do basically with a product spec without a product, you can do in a test list. So they had all of their packages, their whatever they would sell as a testing package, in these test lists, which originally when they rolled out version 6 probably wasn't that bad. They had a handful of packages and everything was great. However, as the system matured, and as customers started to request changes to the way things are reported, to the way things are evaluated, to what components get assigned in their package, you can see from my screen what they had to do, and this is a very small subset here, but they had a package, they called it 245T. Customer A wants something changed in it, like a reported name. Maybe they just want to call the analysis LP406, that's their method name for this analysis. They want to call it customer BAH. Well, to do this, they had to make another copy of the test list. So then what you would have is you would have multiple test lists, which are essentially the same testing package, the same price for the customer, but a customer-specific variant of that. So now over time, this balloons. And then what happens is when they want to make a change, they have to go in and find all of the places where that same customer has modified, an analysis for whatever reason and update it. Sometimes that can take up to hours for them to find all those things, and then they could miss things too. So when they go to run the final report for their samples, they find out then and only then that a piece of information that the customer wanted them to change was not changed, and then they'd have to jump through all sorts of hoops to get that rectified and send them the correct report. So when we met with Karen in Global Labs, one of the things we focused on with their master data design was eliminating the mountains of master data that Karen would have to administer. Karen is the system administrator, and she's the only one. So we tried to find a solution for her specifically that would allow her to maintain and deal with these frequent customer requests or customer changes and not have to be tied up hunting through thousands of records of master data. So the solution we came up with, I would call it a little unorthodox for Labware, because we tried a few different approaches here. We really spent some time in her plan doing some prototyping, thinking through the different scenarios that she would have before we actually came up with this design. So before I talk about the design specifically, I think it's important to highlight some of the things we tried that did not work. We tried to keep this as close to the out-of-the-box functionality as possible because, as many of you are probably aware, when you're working with Labware, if there's an issue, the closer you are to the out-of-the-box functionality, the easier it is to sort of get help from the vendor or get a patch for it. But if you're dealing with something that's heavily customized, it's more difficult sometimes to identify where maybe you have caused a problem versus where the system may have a problem and need to have a patch or something. But we tried using standard product specs. We tried having the customers as the product, but then that hierarchy led to individual test packages being listed under each customer, which is it's putting them right back in the same boat that they were in. And we also tried using analysis variations. So you would have like a default variation for an analysis, and then if a customer wanted to change the reported name, you would have that variation. But to assign those variations, you would have to then configure a product spec such that it would be mimicking the way they were using test lists. You'd have just as much data. And, those were all a no-go because it wasn't giving them anything better than what they had. It was just slicing it a little bit differently. So the solution that we came up with is I've created a table in Labware, which is, as you're aware, very common to do, to create your own tables and add your own fields. And we called it customer test settings. Customer test settings, this table is designed to allow Karen to define anything about a specific analysis component of that analysis that the customer wants to change something about. So what you're seeing on my screen is we have a record in here for customer A and customer B, and then we have one for QC, and I'll get to that in a minute. But for customer A, there's a list of a bunch of analysis here where they've made changes to the way that Global Labs reports these out or handles them. Specifically, you can see here they can define their own rounding rules, their own reported name, whatever the ID is for that test for the customer, the minimum, maximum. It's basically a light version of the product spec. So why is this better than using product specs? Well, it's only defined once in the entire system for this customer. So anytime a sample is logged for this customer, you can apply their settings and it will just automatically apply them for you. But the maintenance of this is really where it shines because they only have to maintain this in one spot for a given customer's test settings. This also makes reporting much easier because these settings get copied directly down to the sample test and result. Therefore, on their reports, they're not having to do as many joins with supporting tables to get this information. It's just reporting on the raw data. And so here, what you're seeing is their products right now. So their products in their system are really just generic product types. It's the type of product that they're testing, not a specific product, but just a class of products. And as you can see, we've done some renaming, which is very common. So we've got under our product here, we have our test packages. So just like in their old system where they had a test list they called that their test package, we renamed the sampling point table to be test packages because this is really where they're defining the different packages that they'll be selling. And what we're able to do here with this new design was eliminate hundreds of duplicate test packages that were just slightly tweaked for one or two customers. So we've got their test packages listed, and then underneath each test package, you'll have the tests that are going to be part of that package, and then which compounds they want to be required. So a lot of their methods have compounds. They might have 50 compounds, but for this test package, they may only want one or two. And so that's how we're using the product spec in Labware. We're only using it to define which tests and which components of those tests will be logged. But all the metadata about those tests are going to be applied from our customer test settings table. All right. So in the event, what I'm showing you here is in the event that a customer does need to change what is provided in a test package, they can create what they call a test subpackage. Now, in normal Labware terms, this would be your product grade. The only time this would be used is when the customer would like to add maybe an additional replicate of a compound or another replicate of an analysis or something. It is not, however, used to change any metadata about that test. It's just for what gets assigned. And that's an important distinction because you could get down a rabbit hole here where you have a sub package for a customer and then you start listing out all sorts of changes in there that make it very convoluted as to where the source of truth is, for the customer settings for that specific test or group of tests. So another reason why we wanted to move away from using the out of the box the test list was because they log in all of their samples for a given customer under project. So they use Project Manager. And when you use Project Manager and you log samples to it, you have the ability to log them in using group login, which is what you see on my screen on the right. Unfortunately, though, when you're using group login and you're using a test list, it doesn't show you the individual tests that you're going to be assigned to the samples. So by migrating them to use product specs, you can now see all the way over on the right, although this is only one test, but if there were more, you'd see more. You can see exactly which tests are going to be assigned to each one of these samples. And another thing that's really useful here that I want to highlight, on the screen on the right, the customer that's listed on this project is the customer that's ordered the testing. It's not necessarily the reporting, the customer test settings that are required for reporting. For example, and where this is most useful, a lot of times you'll have a company send out samples for testing for another company. So basically, company A sends it to B, which then sends it to Global Labs to test. But when they send it back out from Global Labs, they want it reported for the main customer, the actual parent company. So in this case, what we've done is the customer that's on the project is who's basically ordering the testing. But on the right, where you see the test settings defined for each of the two samples that are going to be logged in this project, you can apply whichever customer settings you want, which means you can have customer A order the testing and you can report it out with customer B's settings. And this is very powerful. So getting back to my previous example, I'm just going to back up a couple slides here, where you can see under the customer test settings that there's a QC record. not only can we use this for customer settings, we can use it for internal differences as well. So when Karen does some QC samples as part of her batches, she can use our new functionality to apply special, metadata or limits to those without having to go through setting up all sorts of product specs. If you log in a QC sample, it gets these limits, and she doesn't have to look any other place for it. All right, so, I'm sorry. This is actually the screenshot I was trying to highlight. Over here on the side, you can see, because we're using product specs, that you can see the individual analysis that's going to be assigned to each of these samples. This wasn't possible before with the test lists, right? That LP406 on the end. All right, and after logging, what I want to highlight here for you is on these two screenshots, you can see that the two samples that were logged in this project now, because I chose customer A's setting for one and B for the other, even though they're the same test and the same project, two different samples, they each have their own unique customer settings. So as you can see in the screenshot here, I've highlighted 245T, and you can see that it has a test limit of 0.04. But on the second screenshot, customer B has a different testing limit, right? So that's really where the flexibility comes in with this. But I can't emphasize enough, the real benefit of this is to have this information in one place. She doesn't have to go, through multiple tables to define this. She defines it in one place, and the system just knows what to do with it. One point I wanted to make, though, on the design consideration that Bill was talking about earlier, obviously you can see here we're using, we're using very specific naming for our analysis. So in their case, they're using their method numbers. That's something internal to their company. They mean something to the users, and so they decided to use them on their analysis. Not everything in our design considerations is set in stone. It's a consideration. There's pros and cons to everything. All right, so if you see things here that don't quite line up with some of our best practices, just know that we did our due diligence to make sure that any design decision we made for them met their needs and wouldn't back them a year or more. Okay, so here's a slide of some benefits that were gained here, but what I'd like to do is just turn it back over to Karen for a minute and let her sort of in her own words say, or let you guys know, what benefit she really sees from this, because she's the one that actually is going to be using this system. So I think it's important to hear it from her. You're unmuted, Karen. I unmuted you.
Okay, I'm here. Yeah, the benefits that I see from this it's self-explanatory. There, the redundancies, the errors that we have in the system, every time we have to make a change, we might have to change 50 different places, and we miss some places. And anytime that an error goes out to a customer that we've missed, we're devastated. It's preventable. So there's a lot of work going into our current system, and it's still terribly error prone. I see this system as really simplifying everything. It's going to eliminate a lot of errors. And I look forward to the reporting, because the reporting will be so much easier.
You're not going to know what to do with yourself. You're not going to know what to do with yourself without all the report changes all the time.
Yeah, there are so many other portions of the system that we don't use yet, because it just wouldn't make sense to develop them in version 6, because it's
right. And you spend so much time trying to fix the problems that you don't have time to make anything new. So hopefully now we can spend more time enhancing the system and making use of it versus just troubleshooting.
Absolutely. And I'm sure there's probably a lot of out-of-the-box things that using this design and not really doing major modifications to the basic structure, I think we'll get a lot of more out-of-the-box features that we can use this go-round.
Right. Yep.
So there's multiple benefits every which way we look at it. So I'm thrilled.
Good, and we're glad to hear it. I want to also highlight here, and the reason why I use this example specifically for this presentation was because I really wanted to highlight the importance of the master data design. You can make it work any which way in the LIMS. However, after 3, 4, 5 years, and I know from the poll, that you're really going to struggle enhancing the system or building off of it or maintaining it or reporting from it if you don't get this right to start with. Because you'll back yourself into a corner. Or it takes like a degree to figure out how the system was set up because it's so complicated. And I know sometimes you can't avoid the complexity, but wherever possible, when we work with customers, we really try to understand their workflow, understand how it's going to be used and where the pain points will be, and try to minimize those. And that's something I'm really proud to say, about my team in general. Like, we really take the time to understand where your pain points are and try to alleviate them wherever possible. It's not always possible, but wherever we can, we do. And I think, yep, that's it. That's the end of the presentation. But so I think, Kevin, I think it's over to you now. We're going to do some Q&A.
Correct. So let me go ahead and get the recording stopped.